In this screencast, we're going to talk about double displacement reactions. And in a double displacement reaction, there are two compounds, and they're going to both switch partners, if you will, and they will form two totally new compounds. So if we track this one, we're going to look, calcium is here, and silver is over here. When you switch these, the calcium is going to replace the silver because likes have to replace likes. Likes replace likes. So in this case, we're going to have the metals switching with the metals and the nonmetals switching with the nonmetals. So you can see that on we start with the calcium and the bromine, and on the other side of the equation, the bromine is now with the silver. Another thing to track and keep an eye on is the subscripts follow the charges. So calcium is a +2 on the left, and on the right it is still a +2, and it will be balanced by crisscrossing the subscript. So there's a couple of things going on in a double displacement reaction. You need to make sure that both compounds are switching and that you're crossing the charges. Another aspect to be aware of in double displacement is a thing called solubility. And solubility is the ability to be dissolved. Ability to be dissolved. So when something is soluble, it will become an aqueous solution. AQ for short. Aqueous means that it dissolves in water. If it is insoluble, that means that it stays a solid, and it doesn't become a solution. It precipitates out. So another word you're going to hear is precipitate. Okay. So if you look at our chart up here, you can see that you have some soluble compounds, and these will dissolve. And you can see that you have some insoluble, and these stay solid. So what you're going to use this chart for is when you make a compound, say for instance you make a compound that is calcium hydroxide, you will look on the chart to figure out, is it solid or aqueous. So this chart is listed mostly by the negatively charged part, so our OH. And if we come over here and we look on this side, it says all metals in group 1, all nitrates, acetates, chlorides, bromides, iodides, sulfates. So far we haven't talked about our OH, which is a hydroxide. Now in the second group down here, it says carbonates, sulfites, phosphates, hydroxides, sulfides, and oxides. So down here, it's telling us that hydroxide is insoluble. So we need to then double check our exceptions, and our sulfide over here is, our hydroxide over here on the right side, it says soluble exceptions. So it means that these particular things listed will not follow the rule and not be a solid. So our Ca, as we have down here in our compound, our Ca is listed as being soluble when it's combined with our hydroxide. So we will label this calcium hydroxide here as aqueous because it is marked as a soluble exception. So we use this chart to help us decide, again, if we're aqueous and soluble or solid and insoluble. Okay, so here's a sample problem. We're going to do both parts. First, we're going to predict the products, and then second, we're going to label it for whether they're solid or aqueous. All right, we are looking at two compounds, and we have Ag and we have Sr, which are the metals. So the Ag is going to switch out the Sr. Our first compound that we're going to make is going to be Ag and the CO3. And our second compound that we will make is Sr and the SO4. I need to go back and look at the charges, and we know that Ag is +1 and CO3 is -2. So when we cross the charges, we're going to need to put a 2 here on our Ag. And our charges for the Sr is +2, and our sulfate is -2. So when we crisscross them, they cancel each other out, and so they do not become part of the equation. So it's just SRSO4. So that's part one. Part two is to look at these two new compounds on the solubility chart and decide, are they going to be solid or are they going to be aqueous? Okay. Our first compound is a compound with a carbonate. So I see carbonate is here on the insoluble compounds, and as I read across, I see that carbonate with a silver is not listed, so it is going to be a solid because it is just following the information here for the insolubles. It's not one of the exceptions. We're going to now do the sulfate, and sulfate is up here in the soluble compounds, and it is listed with SR, so that one also is a solid because the SR is an insoluble exception. So you can see that sulfate is here on the left, but SR makes it now become an insoluble, so they're both going to be labeled as solid. So they're two totally different questions here, but they are related. So we have the predict your products, and then we have the component of read the solubility chart and decide what kind of state they are.